Today I wanted to talk about Array.map and Array.reduce in TypeScript and how you can use type variables to tell TypeScript what kind of output and whatever you expect from that operation. Let's look at a map first. So what a map is the ability is basically an iteration through every single item in an array and running a function that somehow transforms each one of the values and creating a new array from the results. So let's create an incremented array, and we're going to run a map against it, n plus 1. And so what this should create is an array of 2, 3, 4, 5, 6. So basically each one of these numbers incremented by 1. Let's see what that looks like. I have another terminal opened with the TypeScript compiler running and automatically compiling to main.js. So we're going to just go ahead and run main.js here. 2, 3, 4, 5, 6. So that's exactly how map works. And what's kind of cool is that you can TypeScript can figure out what you're trying to do most of the time. Let's see, let incremented array. We're just going to go ahead and look at what VS Code is telling us here. So actually, we're TypeScript figure out that it's an array of numbers that we're using. We're running a map, and there's some more info about it. And you can see that in the callback, TypeScript already figured out that the value is always going to be a number, and then you're going to have some kind of result. The U over here is a result. And so what we can do is actually, let's type it out and see if TypeScript can figure out what we're trying to do here with the n plus 1. It should automatically know that what I'm trying to do. So let's see. Yep, as you can see, the U was substituted with a number. So this is how kind of generics work. You pass in a type variable in these little brackets, and it gets used to it gets used in all of these different places to figure out what kind of types we should be expecting everywhere. Because we're doing a +1, TypeScript already knows that a number plus a number is going to result in a return of a number. So right here, number, and we're expecting a number array back. If I move my mouse too much, it looks like it disappears. You can even see here the array, it's a number. That's from this first number over here. It gets a little bit confusing with the highlighting, but what we can actually do is test this out. So what this should print out is array. What this should produce for us is actually an array with all strings in it, and it is. And so if we hover over, we can see now that I hate that when this happens, that TypeScript automatically inferred that we'll be returning a list of strings, that we'll be returning string on every action, and the final result will be a string array. What's kind of cool is that we can actually do some type hinting here. Imagine that we return an object instead. This is actually pretty common too in JavaScript world. Let's say that n was actually an ID, and this is a list of IDs, right? So we might want to do something like this, right? That it's an object of IDs, and we're going to expect value at some point, but we're going to leave it null. And so if we hover over map at this point, it just figures out that it's basically an interface that should look somewhat like this, right? And we can actually enforce something a little bit better than this. It infers this, but maybe we want to actually make sure that this does happen. Maybe this is a function that's 20 lines long or calls to a bunch of other functions that modify or create our object. So we can't always keep track of, that we have all the values that we need. For example, this might be an array of some kind of models. Let's see, what's a good one? What might have an ID? Users, right? So maybe we're creating a list of users that from these IDs and that have a null name because we don't know it yet. Saving it, again, TypeScript figures out that this is what's going on. Unfortunately, our user user model actually requires one more thing to it, and that's let's see, age, right? But because we didn't specify it here, and we just let TypeScript infer what's going on, it only thinks that ID and number or ID and name are required. So what we're going to do is create an interface for a user. It has an ID, which is a number. So now we actually enforce that it's always going to be a number. We're going to see there's a name, and that's going to be a string. And now, instead of the map assuming it's any, and we'll let you put anything in there, we're actually enforcing that it's always going to have to be a string or null. And lastly, we're going to do, well, let's just put that in here. So we can just do this, and TypeScript will automatically make sure that the return object has these two properties with those two types. Now, if we add another property here and we say that, you know, every user needs to have an age and it has to be a number, otherwise we should throw an error, TypeScript already lets us know. Hey, argument of type, property age is missing in type whatever, required in type user. So it's basically letting us know that what we're returning is missing a property. And that's kind of the power of these built-in generics, that you get to specify that you can have an array of users. And whenever you change the interface, TypeScript already immediately lets us know, hey, we're actually missing that here. And that's something that you would not have been able to do with just the built-in hinting, or I guess TypeScript figuring out what's going on. Reduce is another beast, and this is actually how I discovered the generics. How I discovered the built-in generics. So let's go ahead and just delete all of this. What we're going to do is try to do a reduce, and a reduce basically lets you iterate over every single element. And it's kind of like I want to say an accumulator, right? I think that's actually what it's called. So we're going to call this a text output. So what happens when you do reduce is you get a function with the previous value. So every single time this function runs, it updates some kind of value or returns some kind of value that we get in the next iteration. So current, all right, so let's see, val. And then we have a current value, which is the value that we're iterating through. So the first time that this function gets run, previous value is going to be actually empty, and we can specify what the default should be. So if we say that it's an empty string, the first value will be the previous value will be an empty string. Current value will be foo. The second time that it runs, the previous val will be whatever we returned in the first run, and the current value will be bar, and then baz, and so on. So what we actually want to do is concatenate these together. So if we do this, the first time we run this, and let's just do console log here. That should have compiled immediately. Foobar baz. Okay, so what happens is that the first time it gets run, this is an empty string, current value is foo. We add these together, so the next iteration is going to be previous value foo, current value bar. The next iteration will be previous value foo bar and current value baz, and then we return the final output. Now, TypeScript type hinting is pretty good. If you read through this, you'll see that it's an array of strings. Yeah, they've got that right. Callback function, the previous value will always be a string because of what we're doing. Current value will be a string, and the final output of the entire operation will be a string, and initial value is string. So, a lot of stuff got assumed just based off of our variables, and TypeScript is pretty smart with all of this. And if you try to run, I think, what, toString on a string, that should error out. No? Whoops, I guess you can actually do that. Perhaps this, there we go. So if you try to do divided by 2, you'll see that you can't just do a divide by 2 on anything, or on a string. It has to be a number, a big int, or whatever else. So TypeScript knows that the result of this is going to be a string, 100% sure. However, I found myself in a situation where there were too many complex actions, too many diverging trees, let's just say, the diverging if and else statements, where TypeScript just could not figure out what it is that I was hoping to achieve. And I tried setting types for all kinds of things. Output types, like this was like, I don't know, some interface that I needed to use, interface of some kind, and that didn't work. And I tried to set it here as that the previous value will always be whatever, or the current value, or I tried to cast the output as a certain value, but TypeScript couldn't figure it out. And I think it's just because, you know, it was a lot of logic and too many ways that TypeScript couldn't really foresee what I was trying to do. So what you can do is pass in the u, the type variable u here, and that'll kind of get distributed automatically to all these different places. When you pass in whatever type, TypeScript will immediately assume that the initial value will be of that type. The final return, the return of the reduce function will be a u. The final result of the action will be a u, and the previous and current previous value will be a u. And the current value is going to be a string because it knows that that's what the input array has. So this is awesome. I'm going to go ahead and just say it's going to be a number, and you already see that there are some issues here. Previous number, what, blah, what? You can't. String is not assignable to a number. This should actually work. I mean, this will be an NaN, but yeah. And that actually works, and that tells you that it's fine because we are creating a number, which is going to be not a number. But, you know, so that works. And again, we can do more complex actions with this. And note that when we did the array, our type variable got automatically translated into an array of type variables, right? So we didn't have to say that, hey, it's going to be the u is going to be, I don't know, like a string, or wait, in this, yeah, like a string array. No, we actually just put in string and it distributes that correctly. So in this case here, the number has to be the final output, and then it gets applied or assumed that the type of the final output is going to be the type of the initial value and the previous value. So this is just something fun or something to keep in mind and look at in TypeScript. This kind of the power of TypeScript is these generics, or one of the superpowers of TypeScript is generics. And I'm really happy that I learned about this because, well, first of all, TypeScript was throwing errors at me, but it also kind of helped me introduce me to the idea of using the autocomplete a little bit more and seeing, you know, what kind of actions I can take. You know, in one situations I can pass in a type variable to make sure that the result is the type that I expect, right? So, you know, again, if this was like a users thing, a user list, right? The array2 is a user list. We might want to have like a user string of some kind, right? So we might do this, and we'll actually just add a comma after each, and so, whoops. And what this would result is actually, you know, oops, I gotta log it. There we go, foobar baz. Previous value, the first one was an empty, so, you know, this needs a little bit of work. But outside of that, you know, you can enforce that this is exactly what happens. Or maybe we'll need like an array or I don't know, an object, right, of some kind. So again, you know, these are things that you can use to help TypeScript help you. These are things that you can do to kind of error check yourself that you really are trying to return the correct value, and TypeScript will yell at you if it's not possible for you to do that. And I think if you're using VS Code especially, it's kind of fun to be able to look at all the different methods that you can pick and how you can enforce type consistency across, you know, across your app, even using methods like search or replace and repeat or whatever else you're trying to look at, you know. I think that's pretty cool. So